In the last video, we took a look at how to lay out parts and program a countertop with aprons and miters using a saw only. Now we're going to add in the WaterJet. This will allow us to change our part layout and increase our yield, especially if our SawJet has WaterJet mitering capabilities. I'm going to remove all the saw cuts from the Voyager so we can work with programming both the saw and the WaterJet through the SaberJet tab. I'll have to go to Machine Profile Select so that I can select the SaberJet as an active profile to enable all my SaberJet functions. One of them being to insert the SaberJet table template. Here we'll see that the SaberJet has very similar saw blade mitering restrictions, along with other limits for the additional WaterJet. I'll apply an auto toolpath of the SaberJet to show that the saw blade can still cut the same pieces in the identical layout. And we will see the same blue saw blade cut paths that we did in the last video with saw blades only. The difference being that this SaberJet has WaterJet mitering capabilities, which this new additional pink toolpath represents. Also note that it's within the pink limits on our SaberJet table template. This confirms that our 58-degree WaterJet cut will be able to completely cut out this inside corner in its current location. Another advantage to having WaterJet mitering capabilities is that we can place our parts much closer together. So let's remove the toolpaths from our parts. I'll use the Undo Toolpath feature within my Auto Toolpath to remove mine. Now I can move my aprons a little closer to the countertop. I'll slide this larger one in, and then I'll use the Join Parts function to align the two aprons so that the overcut miters are aligned and can be cut in one pass. I'll keep the blade kerf spacing in between the aprons because these two edges are straight cuts, not miters. And so now I'll apply the toolpaths again to see more WaterJet cuts applied. Let's zoom in to take a closer look at the colors and what they mean. The blade cuts are always blue, whether they're straight or at an angle, and they'll stop by the over travel distance explained in the last video. This yellow WaterJet cut is finishing the miter that the blade couldn't complete. And we see the same on this overcut mitered edge. The blade could only travel so far, and then the WaterJet came in at the same angle to complete it. This mitered edge the same. Note that all of the yellow WaterJet miter cuts are within the yellow dotted lines of the table template, so they will cut as shown. These circles show a possible error. If we zoom in, we see a red cut path, which means it's a WaterJet straight up and down, even though it's on the end of the apron with an indicated undercut. If there's not enough spacing in between parts and it cannot start with a blade cut, it will not automatically apply the 45-degree miter. So here's where we as humans need to apply a WaterJet miter cut manually. First, we'll delete the WaterJet straight cut that it applied. You can also delete the indicator circles. And now we can apply a manual WaterJet miter to this miter indicated edge. Choose manual WaterJet miter cut, and verify that the settings are correct. Pierce should be checked, and the angle should be set to the angle applied to the end of the apron. And the end that we'll be selecting has the miter indication applied to it. Now we can select the end of that part as prompted below. Then follow the prompts and pick a new point for a lead in. This is also where the piercing will be placed. Keep your pierce point a comfortable distance away from the part to start with. Then as you get familiar with how your material pierces, you may move it closer. Then right-click to finish and close out of the WaterJet application. So this cut will start by piercing in the center of the 2-inch indicator circle, then move across to the end of the miter, rotate into position, and cut the miter with the WaterJet. Another area that we'll look at and correct is the overcut miters. Toolpaths only get automatically applied up to the end of the part. So we will need to extend these cuts out to the end of the overcut miter. This can be done with extender trim to point on our SaberJet toolbar. Select it and then follow the prompts. Choose the end of the toolpath to extend, and then choose the point to extend it to. I'm going to use an endpoint snap. The toolpaths will only extend in their original direction. And I'm not worried about over travels because these are WaterJet paths. The center of the nozzle stops at the end of each arrow. Now that we have all cuts applied, we can see that all yellow WaterJet miter cuts are within all yellow boundaries or limits. And we can see that our 58-degree inside corner miter is within its pink boundary or limits as well. So this layout is perfectly acceptable. You can extend the cuts to the border and order the cuts and send G-code as normal. Let's take a closer look at our limits. The WaterJet is aligned with the blade. When called for, it will lower into an active position. So both the blade and the WaterJet have full table coverage when making vertical cuts. The blade and the WaterJet also share a physical limit. The machine is physically limited in this area, so we can't cut any closer to the edge of the tank when either our WaterJet or blade is pointed in this direction. That is the only physical limitation when the tools are pointed in this direction. And even though it's physically capable, it's not always safe to cut with the WaterJet all the way to the other side. And this is why we have safety limits. When the WaterJet is mitering up to its 47-degree capability, it cannot go past its safety limit so it doesn't cut a hole in the side of the tank. And we'll have to stay even further away if our WaterJet is mitering at a 58-degree angle. So let's take a closer look at some of our physical limits. If we rotate our C-axis 90 degrees, we'll be able to see the WaterJet in front of the blade. Here again, we can see a physical limit. We cannot physically move the WaterJet any closer to the left side of the table in this orientation. So therefore, we have a physical limit. We can miter in this orientation, and within this physical limit, the WaterJet will be pointed at the back of the machine. So the limits depend on the orientation of the WaterJet and its angle. So in this orientation, with the miter angled towards the back of the table at 45 degrees, the only limit that we are concerned about is the physical limit on the left side, if we are within our safety limits as described earlier. Let's go back to a top view of our table template. In most cases, we can simplify these limits. If we would draw a rectangle to the innermost yellow 45-degree WaterJet limits and another at the 58-degree limits. This helps to visualize and verify that our program will run properly without any overtravel alarms at the machine. In most cases and layouts, the inside corner miter is well within any pink 58-degree limits, and any yellow 45-degree WaterJet miter cuts are well within any 45-degree yellow limits. And the blade cuts are within any limits as well. And that makes a good program. Now let's make a program with some flaws. I'll first undo the toolpaths so I can rotate and move the parts into a different orientation. Never move parts with existing toolpaths applied. And then we'll reapply new toolpaths in the new position. And we'll see that even though some of the mitered edges on the left side are outside of the limits, they will still get toolpaths applied in the program. And if we try to run this program at the machine, we will get overtravel alarms. And here's why. This orange dashed line represents a physical limit when miters are being cut towards the center of the table with either the blade or the jet. And these indicator lines point the direction of the miter, which is towards the center of the table. So both of these cuts applied to this edge would cause an error at the machine. Another problem that would stop the machine is this 45-degree WaterJet miter. This mitered edge is being cut towards the outside of the tank, which is okay with the blade, but not the WaterJet, as it would cut a hole in the side of the tank, because it is outside of our yellow dotted line safety limit. And the last issue that would stop the machine is this miter cut, which is pointed towards the center of the table and beyond the limit of the orange dashed line. In order to run this program successfully, we would need to change the layout or the conflicting toolpaths to straight WaterJet cuts instead. Here's how you could get the parts cut out with straight WaterJet cuts in their current location. First, we'll go delete all of the conflicting toolpaths. I'll also delete this straight WaterJet path and reapply a proper 45-degree miter cut. You can use regular delete, or I'm going to use this delete toolpath function. And then I'll go delete all of the problem toolpaths that I've outlined in the purple rectangles. I'll reapply all of these cuts using the manual WaterJet miter cut. This miter indicated edge did not get a 45-degree WaterJet applied to it because there was not an existing saw blade slot in the same direction. We'll want our lead in to drop into this existing straight saw blade slot so we don't have to pierce. Let's input our settings. We'll start with turning pierce off, since we're going to change the lead in to enter into the existing slot. Next, we'll enter in the same miter angle that we used when we applied the indicated edge, which was 45.5 degrees. And we'll select to choose the miter indicated edge so that the WaterJet angle will follow the miter. And as prompted, we'll select the edge to apply it to. I'm not going to pick a new lead-in point yet, As first, I'll reverse the cut direction so that it will enter into the existing straight saw blade slot. So I'll right-click to complete the command and then close out of the toolpath window. I want the lead-in of my arrow to be in the center of the saw blade slot. So I'll choose reverse cut direction and then select the toolpath as prompted. And then I'll extend the WaterJet cuts out to the center of the saw blade cuts. And when prompted, I'll select the toolpath closer to the lead-in. The point I want to use as my start point is the intersection of the existing toolpaths. So I'll choose intersection and then I'll select this toolpath and this toolpath to start my WaterJet cut in the center of the blade cut. And I'll do the same on the lead out. I'll select this end to extend, and then I can extend it to the point, the end of this saw blade cut. When you use extend or trim to point, the cuts will continue in the same direction. We'll use our manual WaterJet miter cut icon again, even though these miter indicated edges are going to be cut out with a straight WaterJet cut. We can choose not to pierce because we'll start in the middle of our straight saw cut. We'll set our angle to 0, and we don't want to imply a WaterJet direction, so we'll choose Select Geometry, Start and End. When prompted to pick a start point, we'll start on the straight saw blade cut side. I'll use an endpoint snap and select the top left corner. Then I'll pick the edge of my geometry somewhere in between as prompted, before I go down and select the end of the bottom left corner. Then I'll click to the left of my part to apply the WaterJet to that side. Now I'm asked if I'd like to pick a new start point, which I would. I'll use the intersection snap and then choose the intersection of the two existing toolpaths. And then we're prompted to pick a new location for the lead out or to cancel. I'll right-click once to cancel for the lead out and one more time to cancel to change the lead in again. And now I'm prompted to select a start point of a new WaterJet cut. I want to start this one in the existing straight saw blade cut as well. So I'll start at the end of this edge, and then I'll click on this edge to define that the toolpath will go in this direction. And then I'll choose this end point of my part for the end point of my cut. I'll click to the left side of my part so the WaterJet cuts on that side as well. And then I do want to change the lead in as prompted, which remember is at the other end. And like before, I'll choose to use the intersection of the existing two toolpaths to start my WaterJet cut. I'll finish this cut by right-clicking to cancel out of adjusting the lead out, and one more right-click to cancel out of readjusting the lead in. So I can pick the start point of a new cut as prompted. This time I'm going to choose to pierce, since there's no existing straight saw blade slots to drop into. Applying the cuts with pierce checked is the same. We still pick the end we want to start from, and we'll click along the edge of the direction that we want to cut, and then we'll select where to stop. Pick which side to apply the jet to, and now we're prompted to click on a new location to apply the lead in. I won't see the update right away when I click until I right-click to cancel changing the lead out, and right-click again to cancel out of the existing commands before you close the window. And then we can extend the cuts to the end of the overcut miter by choosing Extender Trim to Point, then selecting the end of the toolpath and a point to extend it to. Now, all the cuts will be completely cut out and they're all within the proper limits. Extend the cuts and order them as needed, and then send the G-code. Thank you for choosing Park Industries.